All right, 5.6, a summary of curve sketching. So this is just pretty much a section of us combining everything we've done recently and analyzing the graph as a result and the various parts of the graph. So first we have here is y equals x squared over x squared plus 3. Let's find the first derivative, okay? So this is clearly a quotient rule problem. So your denominator is going to get x squared plus 3 squared over x squared plus 3 times 2x minus 2x times x squared plus 3, not x squared plus 3, just x squared. And if you don't know where I got that from, that's from quotient rule, okay? Look up the formula. I did that to the t. And then simplify it, so we're going to get 2x cubed plus 6x minus 2x cubed. Well, it comes out kind of nice, huh? And then 2x cubed minus 2x cubed just goes away. And we're left with 6x. So your first derivative, y primed, is equal to 6x over x squared plus 3 squared. Okay, so that's your first derivative. Let's find the second derivative, okay? Second derivative would be similar story. So it's going to be x squared plus 3 to the fourth, actually. And x squared plus 3 squared times, space, oh no. Derivative of 6x is 6 minus 6x, and then the derivative of g of x would be 2, and right above it, let's have a little more space. 2, bring a 2 up front, x squared plus 3 times the derivative, which is 2x. So it's 4x right there. And 4x plus 6x will be 24x squared. And I'm going to FOIL this right here. Right? So that's going to get us x to the fourth plus 6x squared plus 9 times 6. That, and the 6 I got from right here, that's still right there. And then we're going to get, as I said, be 4x, so it'll be minus 24x. I'll just go ahead and distribute that negative 24x to both the x squared and the 3. So that would be minus 24x to the third. Minus 72x. And then distribute. And what do we have? We have a lot going on here, is what we have. And then put in order 6x to the fourth, minus 24x to the third, plus 36x squared, minus 72x plus 54, over, parentheses, x squared plus 3 to the fourth. And there you go, that's your second derivative, okay? Much longer, yeah, but that's what it is. So, we need to talk about what your x-intercepts and what your y-intercepts are, okay? Your x-intercepts are values that make the original 0. So your x-intercepts is 0, 0. The y-intercept is when you plug 0 in. When you plug 0 in, you also get 0. So your y-intercept is 0, 0. Vertical asymptote, or values that make the denominator 0, we have none. VA, none. HA, you should know from yesterday, power is the same, so with the coefficients, 1 over 1 is 1, so HA is y equal to 1. Critical number, as you can tell, it'll be 0 because it makes the first derivative 0. Right? Makes that the numerator 0. So critical number x equals 0. And I just noticed a little mistake here. If we look over here, when I was doing this multiplying, 2 times 2x is 4. 4x times 6x should be 24x squared. And then when I distribute it, it should be negative 24x to the 4th. And then I didn't distribute the square to the negative 72. So really that should be that. And then this right here should be a 4, which then simplifies to negative 18x to the 4th plus 36x squared. Actually, rather, negative 36x squared, because I subtract them. And plus 54 over the same thing. So how does that change it? Well, a lot. So when we look for our critical, or points of inflection rather, if you factor that numerator, at GCF is negative 18, which makes life a lot easier. And you'll find that 1 and negative 1 are your points of inflection. So when we put that in a calculator, you'll get 1 and negative 1, as I said. And then if you were to find the y value, plug it in the original. We put 1 in, you'll get 1 over 4. You put negative 1 in, you'll get 1 over 4 again. Domains are real numbers. How do we know that? There's no values I actually can't put in. Okay? I'm going to go up here. I know I'm all over the place. I'm sorry. Domain is all reals. And then symmetry is symmetric over the y-axis. Okay? We'll move on to the next one. We'll talk about this problem a little bit more in class, but you cover the basics. Copy this one down. We'll do this one in class as well and cover all the same things we did in the last one. If you want to give it a go on your own, go for it. But yeah, we'll do this together. So we're just going to do two together. We got this one right here. I'm going to go ahead. These are just simple power rule problems. So first derivative, 4x cubed minus 24x squared plus 36x minus 16. Second derivative, 12x squared minus 48x plus 36. So those are your first two derivatives right there. So different things might be asked is the x-intercepts and the y-intercepts. So this is of the original, remember, okay? When I'm asking this, I'm asking of the original. Y-intercept's easy. Whenever you plug in 0 for x, that's your y-intercept, 0, 5. And the only two x-intercepts are 1, 0 and 5, 0. Okay? I didn't factor anything. I graphed that. This was not a factorable one. X-intercepts, y-intercepts, they're right there. Vertical asymptotes. There are none. No VAs. Why? Not a rational function. None. HA? None. Okay. Critical numbers. Values that make this value, the first derivative, 0. I'm going to abbreviate it as CN. Critical numbers. What are they? And your critical numbers are at x equal to 1 and x equal to 4. If you want to find what those points are, you can plug it into the original, though. And then points of inflection. Points of inflection. I'm going to simplify to PI. And we can factor, I think we can factor this second derivative up. So GCF of 12, so take out 12. X squared minus 4x plus 3, giving us x minus 1 and x minus 3, giving you x equals 1 and x equals 3. Put 1 in twice. So your points of inflection are, as an ordered pair, we know When x is equal to 1, the output's 0. And then when we put 3 into the original, which is negative 16. So 3, negative 16. Here we go. There's your points of inflection. If I were to ask you for domain, what is a domain? It's all real numbers. It's a polynomial, so it's all reals. So domain, all reals. And then symmetry. There really isn't. And your test intervals, which we're going to do this together in class, make a chart together, and I'll show you what that looks like. We kind of talked about it in class earlier, but they will involve our critical numbers and points of inflection. Okay? I appreciate you watching. We'll do some practice with this together. These do take some time because you're kind of combining all of the things we've done together. Yeah, we'll keep practicing. Take care. We'll see you in class.